Hey everybody, this is Mrs. Ellsworth. Anyway, tomorrow you have a test, and this is what's just one component of it, so let's make sure that you've mastered this worksheet. I do have one other thing to say here quickly. You're going to be given some extra time to study for this test. You've got your study guide to work on, and this is an opportunity to take advantage of and actually study, and so make sure that you are doing that. Of course, if you don't study, then it's time to assign you something else. So I've got an alternative assignment for the sub to do. Okay? So here we go. Okay, sodium hydroxide. So we need to make this chemical formula for this one. So sodium is Na, and it's got a plus, and hydroxide is OH, and it's a negative. So we put that together, and we're going to get NaOH. Make sure that you're worrying about those capital letters on there, okay? Okay, plus comes down. Hydrogen monochloride. Oh, mono tells me that that is covalent. So this one is just one chlorine. So that means that this doesn't have mono on the front, but that means that there's one hydrogen. So there's just one of each. So it's HCl. Okay, arrows next. Sodium chloride. Sodium is a Na. It's got a +1 charge, and chloride is with a -1 charge. So it's just NaCl. Plus water. We like that one. Okay, and you can't assume that this is liquid or anything right here, so you can't go and put one of those there. That is not appropriate to do that. So let me erase that. Get rid of that. There we go. Okay, so continuing on here. So we've got sodium, one sodium, and one sodium on the other side. One chlorine on this side, one chlorine on the other side. Now, remember, you leave oxygens to last and hydrogens second to last. So there are two hydrogens here, and there's two hydrogens here. So sometimes we forget to look beyond the plus sign and make sure that we get both those hydrogens. One oxygen, one oxygen. This one is perfect just like it is. Oh, excuse my phone. Okay, so next one we've got potassium chloride. Potassium is a +1 and chloride is a -1, so it's just KCl. Okay. Bromine. Bromine is alone. Notice that it is not a compound. This one was a compound. This one is a compound, but notice that this one is alone. So when they're alone, you do not worry about whether or not that they have a charge or anything like that. No, we don't worry about that at all. We worry about if they're special, if they're up on that list of diatomic molecules up above my periodic table, and this one is. So this one is going to be Br2. Okay, they're diatomic. They don't exist without them being doubled up. Okay, potassium again is a +1, and bromide is a -1. You do your switcheroo, and you're going to get KBr. Okay, chlorine is alone. We'll worry about this gas in just a moment. Okay, chlorine is alone, so you don't worry about its charge or anything like that either. You just worry about if it's special when they're alone. And this one is special, so it's Cl2. It's diatomic. Okay, now we'll deal with that gas. We need a little baby G right there. Okay, let's check it out and start balancing it. We got 1K, 1K, 1 Br, 2 Brs. Uh-oh, so we better put a 2. You can't put a 2 here. Can't put a 2 here. You can't split that thing up. You can only put one in front, that coefficient. Okay, so that makes 2 Brs. It also kind of goofed up our Ks. So our potassiums, I'm going to put a 2 over here also, so there's 2 potassiums there. So 2 potassiums, 2 bromines, 2 potassiums, 2 bromines. That's looking good. And hey, look at this. We've got 2 chlorines and we've got 2 chlorines. Well, when they just come together like that, you know that you've got it right. So that's just excellent. Okay, so that one's excellent. Okay, so remember what I said, when they're alone, you don't worry about their charge at all. So here is copper. Okay, copper, we are not going to worry about its charge, what kind it is, and it doesn't even tell us what kind of ion that it is because it's not an ion, it's an element. Okay, this is metal. It's a piece of metal. Okay, so we just worry if this one is special, and it is not diatomic, so we just leave it alone. I will see students go and put phosphorus with a little P on it with a little 3, and no. The only thing, you don't worry about that -3 here either. When they're alone, you don't worry about that. They're just alone. Are they special? Are they diatomic? No, this one is not on that list. So we'll continue here. Okay, so copper 2 phosphide. So copper 2 means it's a +2. Phosphide is P. It's got a little -3. Do our switcheroo, and we're going to get Cu 3 P and a 2. Now that we're done with the formulas, now we can go around and start balancing it. So we got 3 Cus, so I'm going to make 3 Cus over here, 2 Ps right there, 2 peas in a pod, right? I'm sorry. Okay, there we go. There we go. Next thing's next. Number 4. Okay, number 4, we've got iron 2 acetate. So iron is Fe plus 2. Acetate is C2H3O2. And that one is the first column on our purple polyatomic ion chart, and it's got a -1 charge. So this formula here is going to be Fe C2H3O2, and we need to put that 2 in right there outside the parentheses. Okay, then we got plus. Next one is dihydrogen monosulfide, so that's 2 hydrogens and 1 sulfur. So we'll write it like that. So 2 hydrogens and 1 sulfur. We don't write our 1s in chemistry. Okay. Next thing, and we'll deal with the solid after we write out the formula. So it's not in the middle of it or anywhere else or else in front of it. It's after the formula. So iron is a +2. Sulfide is a -2. So it's just those cancel out. So they're just FeS. Now we'll deal with that solid with a little baby s right there in parentheses. Okay, next formula, I gave it to you, so it's HC2H3O2. Okay, that's fun. Okay, now let's go ahead and balance this thing. I want to tell you a secret. Okay, the secret of chemists. Notice that this C2H3O2 stayed together over here. It's still C2H3O2. It didn't break apart or anything like that, so you can treat this like it's a single atom ion. And that's pretty exciting because then you can actually notice some things pretty easily because you got some other H's in here, and so you can really kind of get turned around on some of these if you're not careful. But since this stays together, use that information and just keep these H's separate from the other H's. Okay. So next thing I got here is we've got 1 Fe, 1 Fe, 1 S, 1 S, 2 H's, that's not in the acetate ion, sorry, and we got 2 H's here. Okay, now we got 2 acetates, and we've got 2 acetates here. So that works out great. Just get rid of this extra fluff here, and that is beautiful. Okay, moving on to the next one. Okay, so this one's a little bit more of a challenging one. I thought that this right here was a good challenge, worthy of physical science students. Okay, so calcium carbonate. Calcium is a +2. Carbonate is on your purple polyatomic ion chart. It's CO3 with a -2, so that works pretty nifty. So you're just going to get CaCO3. Make sure that you're keeping your capital letters where they need to be. I gave you the formula for that one, so it's H3PO4. Okay, and then we got an arrow, and we got calcium phosphate. Calcium is a +2 again, and phosphate is a PO4. It's a -3 charge. Okay, so I need to do the switcheroo with this one, and I'm going to get, I'm going to get a Ca3PO4, but we need to bring a 2 down here, so I need to put those parentheses around that. Okay, and then we got water. And we've got carbon dioxide gas. Di means 2, so there's 2 oxygens. Carbon, there's just 1, so CO2, and a little baby G for gas right here. Okay, so that's, this one right here is quite challenging, and it's good for us to be challenged occasionally, right? We got 1 calcium and 3 calciums, so we're going to start with right here at 3. Okay, we got 3 carbons. Notice that this CO3 got broken up somewhere, so you can't go by a carbonate ion. Now you can go and deal with this phosphate right here. Here's a phosphate, 2 of them, and here's a single phosphate over here. So you can do that so that you, because when you look at all these O's in here, you can get really kind of mixed up a little bit. So let's keep going with this. Okay, so I got 3 calciums, 3 calciums, 3 carbons, and I'm going to make 3 carbons over here. Now, I'm not going to deal with the O's till last. H's are second to last, so I'll deal with these PO4s. Okay, and there's 2 of these over here, so I'm going to put a 2 in front of this one. Remember, you can't put it in the middle. You can't go and add stuff to it. Okay, okay, now I've got 6 hydrogens, and so I'm going to make 6 hydrogens here. Okay, and now let's look at those oxygens that are not in the PO4. Okay, and I've got 3 oxygens here, plus I've got 6 oxygens right here. And so it makes 9 oxygens over there. And look at this, 3 times 3 is 9 oxygens over here. So that's beautiful. So let me get rid of some of this fluff here. And that is gorgeous. So I'll go ahead and circle that. And here we go. And that's a good bingo. So that's what we got. And you've got one problem like this where you've got to write out all the formulas. And then you've got 2 or 3 other problems where you just have to write the, or I provide all the formulas and you just have to go and balance it with the coefficients in front. Okay, so I will see you later.